Steve needs a water after that talk. He set me up. What can I say?
That was the purpose. I was supposed to set you up.
How many people in this room work on the GTF? How many people, keep your hands up, please. How many people have worked on the GTF? How many people wish they worked on the GTF? Unfortunately, I had that opportunity. So I'm Bob Saia, and I just want to talk a little bit about the GTF, and you guys know it probably much better than I do. You know, I'm an engineer, and so it's hard for me to understand some of these concepts. When in 2004, Pratt & Whitney had been selected to power the 787 by Boeing. We were the first engine selected. I don't know how many of you may have known that. And we made a conscious decision not to participate on the 787. We were very active with Steve's team on the V2500, and we were in the process of finishing certification on the GP 7200, which was powering the A380. And so we had a lot on our plate, and we elected, again, not to make a major investment on a new engine program. In late 2005, as the GP 7200 was nearing certification, the president at that time, Steve Finger, asked me to move from the GP program and to take the lead in this new product that we were going to call next generation single aisle, the geared turbofan. And so he gave us a good budget, gave us a real strong cross-functional team with really two objectives. One was to mature the geared architecture and put that on the 130 to 200 passenger commercial market segment. And with that investment, design a high compressor, a combustor, and a high pressure turbine that could be used by Pratt Canada so they could power the large business jet fleet, which was in the 12 to 18,000 pound thrust category, significantly higher when all of their product experience was. And Pratt Canada was successful in launching the PW800, and they now power the Gulfstream 500 and 600, which build about 60 to 70 aircraft annually. So it's a very, very strong platform in the business jet. So in 2006, as we made that selection not to play on the 787, Boeing was really struggling in that aircraft development program. But at the same time, they were very successful in increasing build rates, both Airbus and Boeing, because fleets were upgrading, modernizing equipment, airline fleets, and there was a lot of route expansion. So both Airbus and Boeing had no need to create a new aircraft that we could put a geared architecture on. So our strategic approach that we had hoped to get on an Airbus and Boeing program wasn't going to be successful. So we elected to go after the Bombardier C-Series, which is now the A220, and the Embraer 190 family, which is now the E2 family, and use them as our platform, and then hopefully be able to penetrate Airbus and Boeing at a later date. But we needed to do something different because Boeing and Airbus had no need, and although Bombardier needed a power plant, it wasn't clear that that airplane would really get launched. So what we elected to do was to create a strategy, a paradigm shift in engine development. In the 1980s and the 1990s, typically engine fuel efficiency improvement was 5 to 6% at the cost of higher engine cost, manufacturing cost, and higher maintenance cost. So we took the objective of leveraging the geared architecture to guarantee greater than 12% fuel consumption, at the same time, a 20% reduction in maintenance cost, with a 50% reduction in nitrous oxide, which is a very significant player for takeoff and landing fees in Europe. And more importantly, to now allow a 150 passenger airplane to operate 24 hours a day in really noise-sensitive airports like Amsterdam and London. And the difference between a geared architecture in noise and a conventional engine, sorry, Steve, a V2500, is about 20 decibels. That difference is my voice without a microphone and the voice and the sound coming out of an egg beater. That's about 20 decibels, or in a regular egg beater or drink beat. I lost the word, but you don't understand what I'm sounding. That delta, 20 decibels, would allow now an airplane to leave at 11 o'clock, between 11 p.m. and 6 a.m., making it a very significant contributor to overall utilization of a very expensive aircraft. So our real focus then, we had really two major focuses. One was to complete the technology maturation of the geared architecture, because we still had a ways to go to make sure that we could make it a commercial product. And then secondly, find a platform. So our first focus strategically was to build a demonstrator. And that demonstrator is in the back, on the back wall in the center of the room here. And that demonstrator was an 80-inch fan with a 3-to-1 gear ratio using an existing PW 6000 core. And our overall objective there was, with that demonstrator, to demonstrate a 20% fuel improvement relative to the 6000, and then to demonstrate the noise, installed noise, at the airplane level. So as we then created the design or the technology characteristics of that demonstrator, we ran that demonstrator in West Palm Beach in the middle of 2007. Late 2007. We then installed it on a Pratt-owned 747 in the middle of 2008, and then successfully installed it on an Airbus A340-600, which was an experimental airplane that we were participating in a technology program with Airbus. And that demonstrator really became the focus of how we were going to make the geared turbofan real. And the success of the Airbus flight test program really drove what we know today as the Pure Power PW1000G. Now, as we were going through this, we had a lot of conflicting objectives. Got to be good in fuel consumption, got to have low manufacturing cost, no exotic materials in the turbines, got to have 20% lower maintenance cost, but at the same time delivering the fuel consumption and the noise reduction. So there are a lot of conflicting objectives. So the team, both a technical team as well as the business teams, had significant hurdles to address, and they had to determine how to solve those problems with some innovative solutions. At the same time, we had to overcome the skepticism of the gear. Both Rolls-Royce and GE were really downplaying the execution of a geared architecture. GE was calling it old technology, poor in durability and reliability. And so we had to really understand the gear, because although we had some demonstrators prior to this particular test vehicle, they really weren't flight worthy because of the characteristics of the gear, the oil system, and the ability to take flight loads. So the technical group had some really significant hurdles that they had to overcome. So our engineering team teamed with Sikorsky and Pratt Canada, which had a lot of geared experience. We built a gear facility in East Hartford, and through a lot of hard work, committed testing, we were able to really establish the right architecture to make it doable on a wing. And in that rig, we were able to run tests that we couldn't do on an aircraft, run with contaminated oil, zero Gs, significant loads on the structure of the gear to make sure that the gears would stay in proper mesh. Because if the gears stay in proper mesh, they last for infinity. But when they don't mesh right, they'll destroy themselves really quickly. So we had to really understand how to handle that. At the same time, we had to overcome the skepticism in the industry, because everybody believed that Pratt was reaching, and if gears were so good, why wasn't Rolls-Royce and GE reaching for a geared architecture? So we had to find what I'll call industry influences, both at the airplane and the OEM level, so that they would understand what we were doing. We kept them as part of the learning curve of the establishment of a geared architecture. A lot of communication, a lot of engagement, a lot of visits to them at the airlines or to West Palm and East Hartford to really show them the characteristics that we were finding as we were going through this technology maturation. Key airlines were American, Lufthansa, and Delta. At the same time, we took a real strong media presence. We were working closely with Ave Week, Flight International, some of the major European journals, doing interviews almost one a month. And we were successful in getting over a dozen journal covers as we went through our development, really enabling us to get a lot of market intelligence and press at really very little cost, but at the same time to get the awareness and the industry acceptance that the gear was real and it worked. But at the end, it all dealt with execution, doing what you say when you said it would be done. Now, we really had some really challenges. So we made this agreement to fly this geared architecture on an Airbus A340. Airbus ran every test that they would do to certify a commercial engine on their aircraft, 34 flight cards. And we had to make sure that we could pass that testing. So as we ran the engine in West Palm Beach and on our 747 flying test bed, we uncovered some major issues that were associated with the demonstrator. They were unique to that architecture, not necessarily something that today's GTF would experience, but we couldn't afford having a thumbs down by Airbus, especially since they would really be the judge stating that we were innocent. So as we ran the sea level and the 747 test, we understood where the limitations were, and we worked closely with Airbus. So as they ran their 34 flight cards, they didn't run into any of the operational issues that we uncovered during our own test program. And in most cases, they didn't even know that those limitations existed. So it's understanding what needs to be done, how it needs to be done, risk mitigating what you know, and setting expectations for success. Again, doing what you say when you say it will get done. And that's really the key element of why we're here today with a very successful program. And I always, when people would come up to me and say, well, you've done a great job on the GTF, I look at myself as a conductor in front of a lot of talented, expert musicians. And all I needed to do was to make sure that I stood in front of them and let them play the music. And this group did that. Thank you.